as much as we're going to get, so we'll probably get started. Welcome to your Group 4 planning project planning meeting. My name is Mr. Galvin. For those of you that don't have me in class or know me in some other way, this is Mr. Mescalato, for those of you that don't have him. Neither Miss Ernie nor Mr. Imazumi could be here today. I believe both sick. I know Miss Ernie is very sick. Did you guys have her for class this morning? Yeah. She was in bad shape, to the point of, like, she came over and looked at something on my computer and I immediately, like, hand sanitized my entire computer. The other two couldn't be here, but anyway, what I want to do today is give you kind of an overview of what the Group 4 project is, kind of what it's going to entail here at Harriton, and then some important stuff like due dates, kind of what's expected of you, and near the end of the meeting I'll pass out to you what your groups are. I'm smart enough to know, I've been doing this for enough years, that if I pass out what the groups are right now, you won't listen to a word that I say for the next 5 minutes or so. Group 4 project, right? Group 4 is the sciences within IB. All of you chose to take a Group 4 class, right? You need to take chem, bio, or physics, okay? The Group 4 project is a requirement of all students trying to get the IB diploma. You have to participate in and complete a Group 4 project, which is an interdisciplinary science project which combines all the students that are taking different disciplines of science within the IB program. So basically what that means is students from chemistry classes and bio classes and physics classes working together collaboratively on a science project of some sort. What that project is can take many different flavors depending on what the school decides to do with it. But we have a certain way that we're going to do the Group 4 project here this year, and that will be your Group 4 project. Okay? And it's kind of explained to you in the sheet that was given to you. Okay? So it's a requirement for the IB diploma. The IB does not want a report from you or anything like that. It's not like your internal assessments where we pass in your work. It's almost entirely internal to Harriton, but what we have to do is we have to sign off on the fact that each one of you completed a Group 4 project so you can get your IB diploma, okay? And it's always done in the junior year, and then next year you do not have to do a Group 4 project. You would be done, okay? Unless for some reason you do not complete a Group 4 project this year, in which case you would then have to come back and do it next year with the juniors next year, but that's not going to be the case. All right, so the Group 4 project, as it will be at Harriton this year, is collaborative kind of research / experimentation project between different people from different classes, right? We put you into groups of 3 or 4 people. Like I said, I'll give you those groups in a little bit. Just about every group has a chem, a bio, and a physics at least member from a class in there, but there's not enough physics people to go around because you guys are very special people. So there are some groups that are just chemistry and bio, right? They're just chemistry and bio. But a lot of groups have the one physics in them. As a group, what you're going to do is you're going to pick a topic. It could be anything that interests you scientifically. It could be, ocean water and the study of ocean water and the habitat of oceans. It could be, it could be plastics. It could be, anything scientific. I mean, the range is huge. What you want to pick is a science topic. But what the project is trying to get across to you is that there can be a greater understanding gained about a scientific topic when it's approached from multiple disciplines like biology and chemistry and physics and engineering and earth space science. Depending on the topic, different ones apply. But you get a greater overall understanding of it if you don't just isolate what's the chemistry of this process and only study that. If we were to talk about, say, global warming or something, or what's the biology of the impacts of global warming, and that's all that we look at. Synthesizing what different scientists do in their different disciplines together should build understanding and not just instead be 2 independent pillars of separate understanding. That's what the Group 4 project is supposed to do. You pick a topic within your group, you agree on a topic. You research that topic, paying special attention to looking at it from at least 2 scientific disciplines, and those could be any 2, and they don't have to be ones that we study here at Harriton. If you think that Earth space science, we'd say, is a kind of scientific topic, and chemistry are 2 great aspects to look at the phenomenon of global warming or smog production or something like that, then that might be very, very appropriate. If you want to look at ocean water as a habitat, these are just examples I've come up with off the top of my head, then perhaps biology and chemistry might be ones to look at. If you want to look at, efficiency of motors and machines or something like that, perhaps physics and engineering would be the two things that you would look at, right? These two sciences. It does not have to be the sciences represented in your group. If a group of biology and chemistry students want to do a project and look at it from the aspects of astronomy and engineering, fine, right? It has nothing to do with what science class you're in, other than we mixed groups up to give you group members from different experiences within the program, okay? So there's kind of two aspects to it. You'll do a research project, right, where you look at your topic from different points of view and find out information from a couple different points of view and synthesize that together, hopefully to present in your research paper, kind of some novel understanding. Here's what, Earth-space people always talk about when they talk about global warming. Here's what chemistry people always talk about when they talk about global warming. But if you look at them together, you can actually maybe see some interesting new information that's not always written about, because it's not written about in a synthesized kind of way. So a research paper, it's got to be a minimum of 6 papers, and it's a combined effort among your group, okay? Minimum of 5 reputable sources. In there you can talk with your advisor. You'll be assigned a teacher as your advisor for your group, but what a reputable source is. But if in your MLA source code, all you list is Google, that's not a reputable source, right? Actual source is where you get this information. The second aspect of it is you're going to do design, plan, carry out, look at the results of, and experiment, which could either showcase something that you learned about your project or be an extension about something that you don't yet know, but you want to experiment and see further about it. It's meant to be a real novel experiment, something that's not probably typically in high school lab manuals and that kind of stuff, right? It might be, in past years, we've had people look at the effect of different gases in the environment and their effect on global warming. And they took like a fish tank and they sealed the fish tank and they found a way to inject different gases into the fish tank and used like ultraviolet rays going through and saw, the temperature difference in the tank over a certain number of times depending on what gas was in there and what concentration was in there. They designed an experiment to mimic what they were studying and then looked and actually saw the data, analyzed the data, looked at the strengths and the weakness of the experiment, whatever. If it's, ocean chemistry is your idea, if you're ocean water or something like that, and you want to look at the effect of, different salt concentrations on plankton or whatever, right? You can do that, right? As long as we follow the IB ethical guidelines. I'm pretty sure plankton actually qualify. We cannot go purposely killing the plankton. I don't know. We'll have to read that. If you use live things like plankton, we have to make sure that we're treating the plankton well.
If they begin alive, they have to end alive.
That's your best effort.
But if they start dead, can they stay dead?
If they start dead, they can stay dead. Your hands and feet?
No, like someone else's hands and feet. Like donated to science for this purpose of our experiment.
How are you going to get someone to donate
Sure.
cancer?
Yeah, you could do that. As long as, talk with your advisor. As long as it's legit, then we'll discuss it, and I think that's fine. If you wanted to actually look at, if you could get cadaver hands, I don't think that would be a problem, right? From some guy on the corner, not a good idea, right? And the trafficking of body parts, we're not going down this road. Talk about it with your advisor. And I might also refer you to the school's legal counsel at the same time. But you can't do anything like, specifically, although in science we do it all the time for the best of purposes, you can't go, killing a bunch of lab mice or something like that. That's not what we're doing here. You can't, there's one written a few years ago where it was used as the IB example of what you can't do. Someone looked at the effects of marijuana on earthworms. You cannot feed marijuana to earthworms. It is against the IB's ethical guidelines for the treatments of animals. You also cannot study the effects of other things on earthworm while you are under the effect of marijuana. That's also flat out not covered under the IB statutes. Yeah, the state of Pennsylvania statutes. Anyway, Design and carry out an experiment which showcases or furthers your understanding of the topic. And it should, like we said, it should be something that you don't find directly in a high school lab manual or online or something like that. We want you to give original creative thought to, wouldn't it be really neat if we looked at this? And design an experiment and carry it out. Now here's what we expect, right? This is kind of real science compared to what you do in, say, my chemistry class all the time, which is very much prepared science for you. It's, we want you to see this. You might not know what the answer is, but professionals have decided that this is the technique that you're going to use so that you can see easily the effect of A on B, right? You guys will be designing an experiment from scratch. And we want it to be at least complicated enough that, and this is going to sound terrible, that we really kind of expect that you're going to fail at it a little bit. As in, try something and find out, I didn't get any good data. I wonder why I didn't get any good data. Perhaps the design of my experiment wasn't quite right. Maybe I should go back and look at that. Maybe we should redesign this, and instead of using this concentration, use this concentration because this gave me no results whatsoever. Or maybe my inclined plane that I'm looking at with friction to the surface, maybe the surface was just too slippery. I got to go back and at least start with something that's a little bit, has a little bit more friction to start off with before I start looking at the difference in acceleration down this ramp or something like that. It's something that we really expect, just like a real life scientist would do. You don't know how it's going to turn out, and we expect that you'll probably spend some time trying, starting, stopping, reconfiguring, and starting again before you get to the end of the project. We also don't want you to just hit dead ends and go nowhere, which is where your advisor really comes in. Your advisor's primary role is to help you brainstorm and kind of weed out maybe things that might not work from the get-go, right? And maybe your advisor will be able to give you some advice on, I like your idea, but I really don't think you're going to get anything useful until you maybe look at it from this point of view, or you really think about this material that you're using here. In a perfect world, you design an experiment, maybe think about how the results came out, and maybe try it again, which is an aspect we don't get to do in class. You guys do the design criteria for your lab portfolios, and you, in your conclusions, talk about what could you possibly do to improve errors in the lab. But what we don't do is actually go back and redo them again and say, my results would be different had I not blank. And that's what we kind of expect in the Group 4 project. To see not just, here's an experiment, here's the results, look at my pretty graph. But more, here's my thought process. Here's how we went through this. Here's the problems that we encountered. Here's how our data supports that. Here's how we made an intelligent decision about what to do next. And here's how we changed this, right? Here's our difference in data. That worked, or maybe it didn't work, and here's why it didn't work. At the end of the project, you do not have to have some big, finished, perfect science fair type project, right? I mean, the research paper, hopefully you finished that, right? That's the research paper, that comes to an end, it comes to a conclusion. But the experiment, if at the end of your experiment time and it's ready to kind of put things together and present your Group 4 project, if you tried A and it didn't quite work, so you thought about it and made the next intelligent step, and you tried B and that didn't quite work, then you thought about it again and you had enough time to try it again with maybe a different setup or a different configuration, maybe you made a little bit of progress, but it wasn't perfect yet. That's where you stop. You're done. You present that. You talk about the process of the science that you did, the process of the engineering that you did. The results are really kind of secondary to what we want you to get is a real world kind of everything doesn't work all the time type experience. And that's what we want you to focus and think about when you do the design of the experiment part of the project. Okay? Don't look for something that's so easy it can be done in a half an hour. Your advisor will probably tell you that that's not what you want to do anyway. Really use this as an example, as a place where you can try something on your own and understand that we don't care if you fail and try again. That's what we want you to do, okay? Now at the end of the project, let's get to the end. It's funny, we never put this on the sheet. When is it due? Okay, March 5th, okay? March 5th, a little over a month from now, which is just enough time for you to procrastinate for about 3 weeks and then cram it all in the last week of February, right? Yeah. Please do not do that. Please, please, please do not do that. You're going to be working in groups, and group dynamics only get more stressful the closer you get to the due date of a project. Yes. In maybe 10 minutes, 5 minutes, something like that. Yes.
Oh.
Yeah, go ahead.
Oh, thank you. Okay.
Yep.
like no negotiability in the group?
Yes.
I'm like, well, sometimes there's like some kind of what?
No, no, no. If there's like a group of 3 and we find out that randomly we put all 3 people in the group and they're all dating each other, no, that group's staying together. Right? So no, the groups are the groups. Okay. So what do you need to have at the end? IB is a very close-knit community, right? At the end, what you need to have is 2 things. Number 1, a research paper, minimum of 6 pages described on there. Your advisor can tell you more about it, but we really don't need to tell you much. The focus of the paper should really be on interweaving the 2 different disciplines that you look at and showing how looking at things from 2 different points of view can really lead to greater understanding, right? Yes, it's a research paper on a scientific topic. Yes, you've been writing things like that since 4th or 5th grade. There's a little different aspect to this. Research paper, that's got to get handed in. But also you need to prepare a physical display of your Group 4 project, which includes your research that you did and the experimentation that you did. At the end of the project, on a date to be determined, we're going to kind of get together as a group again. We're going to give each group a table, such as this, to present their Group 4 project on. And it could be just about anything you want, right? And people are going to mill around from table to table and look at other people's research. It could be a poster presentation, right? It's pretty straightforward. Most people would think about a poster presentation for visually displaying that kind of stuff. It could be artifacts from the experiments that you did, like say the actual fish tank that you used to pump gases into with the thermometer on the bottom so people can see, oh, I see exactly how they did that experiment. We've had people in past years have like a little, their computer running with like a little 3-minute video on a loop that shows video of the performing of the experiments and what it actually looked like when, you know, people were launching t-shirts out of their homemade t-shirt gun that they were looking at or something like that. And this really ends up being more of like a America's Funniest Home Videos kind of, you know, here's all the problems that we had and laugh at us, that kind of thing. Anything that you want, be creative, right? Your display is your display. However you want to show off the research that you did on your topic, the experimentation that you did, and the results that you got from it, and here's our Group 4 project. Put it on a table. It's got to fit on a table, but other than that, that's all we ask, okay? There are rubrics in your packet that you got for both the research paper and the presentation at the end. That's not meant to be restrictive, it's just meant to lead you in terms of what you need to make sure that you present, not in terms of how you choose to present it, okay? But I would say if it's nothing but just like a tri-panel poster, that's probably the bare minimum. We expect that maybe you'll be a little more creative and showcase your work a little more than that, okay? All right, you got groups, pick a topic, you approach it from 2 or more disciplines. We always say 2, but if you want to approach it from 3 different disciplines, that would be just fine. And of course, you know, we definitely look pretty favorably upon, you know, a more difficult project. Not saying that you'd automatically get a better grade or something like that. We can talk about grades for a second too. But you know, if you do something more challenging, yeah, of course we give you credit for difficulty. Pick a topic, approach it from a couple different disciplines, pick an experiment which showcases your topic, perform the experiment, right? If it needs some redesign, it needs some redesign. Scientific process, we talked about that. In a month, present both your paper and your display on a table, and we can all walk around, eat donuts, and admire each other's work. Okay? Now, grade, very simple. As far as Harriton is concerned, your Group 4 project in total will count as a test grade for the 3rd quarter. Okay, a test grade for the 3rd quarter. However your teacher handles that in your class, it will count as a test grade for the 3rd quarter. Okay? Everybody in the group gets the same grade. Okay? Unless it is obvious to the advisor that there is obviously a non-equal distribution of work. It's very difficult for an advisor to see that, right? It's easy to see when groups are dysfunctional, but it's very often hard to know, okay, well then this is the person that's really causing that problem, and therefore grades should be different, okay? You really need to work with each other on this, which is why you get graded on your personal skills for your IB portfolio. That rubric is also included in your packet, okay? We grade you on personal skills. That goes in with your internal assessment portfolio, and it's basically how well do you play with others, right? That's basically your personal skills score, okay? March 5th, worth the 3rd quarter test grade. Information about the project is here. You're going to get your advisor. I'm going to give you your groups right now. First thing you want to do very soon after this meeting, tonight by email or Facebook or whatever, get in touch with your group, plan when you can maybe get together and brainstorm, plan a meeting with your advisor very quickly, make sure, as in soon, make sure you're all going to meet with your advisor, right? If I'm your advisor, I don't know how the other advisors will handle it, but if you're my advisor and you're a group of 4 and you make a meeting and 2 of you show up, 3 of you show up and say, oh, the other person couldn't make it, they decided to go to stock club instead. I'll say, well, then they shouldn't have planned it while you had stock club. Come back when all 4 of you can meet. Because I'm not going to go through the process of meeting with a group and then not having someone not be included and whatever. Make a meeting with your advisor, everyone's got to come, okay? And get going as soon as you can. Sometimes experiments go well over a weekend. You can get your experimentation phase done. Sometimes it takes a couple of weeks. Maybe you have to order some materials. Maybe you have to get something from Amazon. Maybe you need to talk to me and order a special chemical or something like that. That can't happen overnight. Again, it just costs like $85 in shipping. But try and start planning ahead of time so that you have time to actually perform the experiments that you want. Okay? I'm going to start passing out the groups, and I'll field any other questions. I'm sorry? Your advisor will go over that with you, but I do, if it's safe enough for you to use in a normal educational program, then I would say yes. Here, take this and start passing it back. Pass them over and then back. What's up? Across, guys, across. See number 1, guys, see number 1, 2, 3? Yeah. They go across, they go across, they go across. See how they're shaded? Did we avoid the IB Junior love triangles?
No, you included them all.
Oh, we got them all. Good, good. That's exactly what we wanted. Are there any questions in the last 2 minutes of the meeting? Any questions?
We're gonna have so much fun. That's gonna be the most fun.
All right, guys, meeting's over. Stay till the bell rings, okay? Thank you.